To understand line balancing in a better way, probably let us go for this video. Today content is on line balancing. So probably we'll be doing like what are the sequence of operations there and what are the how the jobs are carried out depending on the given time and depending on the number of units a plant produces per day or whatever it is. Okay. So I just collected a set of video, but I thought this one will be more apt to discuss in today's class. I'm not switching on the audio side. Okay. Probably without the audio, you can see. There's no audio. Actually, audio is there. I'm not playing with the audio. Usually, the video visual is only. So this is a plant of Mahindra Chakan regarding the manufacturing of trucks and buses. Buses, okay. So it's not directly involving with the assembly units and other things. It's completely showing the factory units and everything on. Okay. I just want to scroll a bit. So this is one of the factory of Mahindra. Just have a look, okay, what they are doing. If possible, you can have a look on the wordings. It is displayed below, right? Production rate is one panel every seconds. Okay, die changes line. See, for each and every time they had to change the die means how many, how that's what you call as the lead time, the setup time between that gap. Okay, so that's taking around 3 minutes for them to change the die. Okay, modular and flexible. We are not going to talk about machinery, so don't focus on the machine. See, this is what you call as a belt. It moves in this way. Okay, the machines are not moving. The parts, step by step process, the parts are moving. Okay, so that's what you call as a conveyor belt. Complete shop area is 9,000 square meters, and assembly is done in 92 stages. Okay, 92 stages la the process by process ಆಗುತ್ತೆ. So they're using robos and auto guns. Okay, before continuing, just focus on what happened a few seconds before. Actually, that unit is coming to that particular point, correct? And the robos and auto guns are automatically fixing everything. Okay. And can you please notice that the unit is not moving during the fixing time? The robos, auto guns எல்லாம் work ஆகும்போது the unit is not moving. The unit is staying at one point. Okay. So such a way the belt is designed. It has to go to that workstation. See, everything is done automated. It goes on, moves to the next level. See, sometimes humans are there, sometimes robots are there, sometimes both. It goes to the next stage. This is what you call as robotic aided manufacturing. Everything is computerized. Yeah, please highlight. Speed is 12 vehicles per hour. How many units they are manufacturing? 12 vehicles per hour. All speed up on it. Okay. So that unit alone is moving. The dyeing, all the assembly things are just working over there. Then it's spray painted. Variant products produced 16T to 19T. See, I'm not good at mechanics or all. பார்த்து தான் சொல்றேன். Okay. Because today's content is directly dealing with this. Okay. They fix the tires. This is done separately. This is the complete body, right? It's done separately. The outer shield is completely done separately. It's not one person working over there. There are many persons working. அந்த மாதிரி எத்தனை பேர் ஒர்க் பண்ணலாம் as per the law it's different. See, this is like capacity planning we studied, right? Installed capacity is 45,000 engines per year. Installed capacity. So this machine has a capability of working 45,000 units per year. Then they go for the test cell. They'll check everything is screwed properly and other things and all. I just want to skip a bit okay. So this is about the detailing stuff. So you call this is conveyor belt, right? Just close this page. If possible, you can just have a look on other cases. Whatever vehicle you like. You get, I just took a set of videos and I found because I'm dealing with Mahendra's case, I found this one, and I found another one interesting. They are making chocolates. Okay, chocolates. If you go for gems, you have different colors in one pack. So how they are making different colors and how they are mixing in one pack, like so everything was done. That was also like very well dealt. Okay, chocolates. If you go for gems, you have different. Okay, fine. So today's content is on line balancing. What do you mean by line balancing? A small theory content we have, then we'll go for the problem. Okay. Because we have seen practically what we are doing in line balancing. Actually, what is line balancing means the full process which is carried on is what you call as balancing. That's a line. Okay. All the process put together. If you are checking for Mahindra, it says like 92 stages are being done. That process involves 92 stages. When we talk about line balancing, if you are talking about 92 stages as 92 processes, it's not going to happen as single process. Okay. The unit will come. Okay, the belt will be moving in such a way. The unit will come. Probably it will stand here for some 3 minutes. Okay. In this 3 minutes, whatever the processes are needed to be done, everything will be done. See, there will be a sequencing. முதல்ல வந்து எதை ஃபிட் பண்ணணும் செகண்ட் எதை ஃபிட் பண்ணணும்னு இருக்கும் so that will be a sequencing done that along with that sequencing they will go for this unit has to stand here for 3 minutes means what are the jobs has to be carried over after this 3 minutes it will move to the other unit it is for example let me take it's taking some 15 seconds to move to the other unit okay so it will stand in the other unit probably for 30 seconds it's not a big job ஒரு main screw டைப் பண்ணணும் அதான் வேலை but it will start for 30 seconds, then it will go for other workstation, and so on. They may be saying it is carried out in 92 stages, but it may not be 92 workstations. Okay, so they will totally calculate how much is the time needed for the machinery to completely go through the process, and what are the things needed, and how many workstations we have to design. That's what calls the line balancing. Okay, see, I'm employing employees. Okay, I have employees, the human capital I have the missionaries. I have to make them everything in such a way they are not idle. Okay. சும்மா சம்பளம் கொடுத்து உட்கார வைக்க முடியாது. Even the missionary is also costly. Even the human capital is also costly. I cannot make them to sit idle. So my intention should be in such a way that I have to reduce this idle time. Okay. So ultimate aim is optimality only, right? So reducing this idle time. So When we talk about line balancing, we'll discuss about how many workstations we need and how many human capital or machineries has to be assigned to that workstation or jobs has to be assigned to that workstation so that everything is done in the easiest way and optimal way. Okay. So definition is nothing but arrangement of production lines, nothing but an arrangement. Okay. But it's not just directly I'm going to arrange, I'm going to do some logical arrangement. And in fact, you can say you can do, you're going to do some mathematical arrangement. Okay. So there is an even flow of production from one workstation to the next. So it's not going to, I stand in one workstation, it might be taking 3 minutes, but my job finishes by 2 minutes and 50 seconds itself. Okay, is that 10 seconds I'm waiting? No, you have to wait because if it goes to the second workstation from here to here, for the next job, it will take 10 seconds. அப்போ இங்க வந்து எவ்வளவு டைம் இருக்கு எனக்கு டோட்டலி I have only 33 minutes because of to use this 10 seconds I cannot use the other job here. Probably the other job might be needing at least 13 seconds or 14 seconds. So it may not be helpful. Okay. So you're going to apportion the sequential work activities. I want to highlight this one sequential work activities because you cannot mix or exchange or you cannot do anything with the sequence. That is properly designed. What is the impact is we'll try to minimize the idle time so that there's no delay. And what are the actions you take? Probably you rearrange the workstations, you add extra machines, you add extra workers or substations or whatever it is. Okay. So line balance. This complete process is what you call as line balance, which is actually defined as line of balance, which is nothing of production planning system. See, it's a planning system. Okay. Which schedules key events necessary for completing an assembly with respect to its delivery dates for the completed system as a finished goods. So here what we do here is we go for graphic displays. So what they do is they computerize பண்ணும்போது இந்த ஒர்க் ஸ்டேஷன்ல எவ்வளவு நேரம் நிக்கணும் what has to be done what has to be done for the next work station which work has to be which work is which job has to be carried on everything will be done. So what principle we use here is we use a principle called as management by exception, which means what are the main thing we have to focus, that will be focused, which means even though my unit will be standing there for 3 minutes, I might be utilizing only 2 minutes and 50 seconds. That's 10 seconds might be a waste only. It's idle only that I'm making the workstation idle. But no other go, it's management by exception. Being on the sequence of manage பண்ணும்போது, you can waste the time. No other issues. That's why it's a management by exception. How we do is we take the tools, PERT, Gantt charts. We have done the diagram, right? Network diagram. We take the use of those. Okay. Here also we're going to draw the diagrams. There we'll call that as network diagrams and other things. Here we'll not call it as network diagram. The same logic is here used, but we call it precedence diagram. Precedence means the sequence of activities carried one by one. That's why we call it precedence diagram. So when we talk about the finished product, it is not involving one operation, right? It's involving many number of operations and everything is properly sequenced. And not only that, different production capacities will be existing for different machines. As we were discussing, they were manufacturing like 40,000 units per year, I believe. Okay, the installed capacity is 45,000 units per year. So the terms we'll be using is task time and cycle time. Task time is the time taken by the worker or by the machine or both. Okay, one job is taking 30 seconds. One job is taking 1 hour and not 1 hour, 1 minute and 50 seconds. So this is how it is measured. That's the task time. Cycle time, the time that will elapse between products coming off the end to the assembly line if the desired hourly production is met. So how long cycle time is complete time. Okay. ஒரு ஒர்க் ஸ்டேஷன்ல 3 ஜாப் போகுதுன்னா அந்த 3 ஜாப்பும் முடியும் போது ஒரு டைம் வருது cumulative value. Okay, cumulative value. How we do in assembly layout is you determine the task involved, you draw the, see this is the steps, probably you might make a note of it because we are going to do this one only. This is the steps involved. You determine that what are the tasks involved, then you draw the precedence diagram, you estimate the task time, you determine the cycle time and assign each task to the work and balance the assembly. Okay, probably this might be needed in case it's theory launch. How are you going to say it's an efficient mix? The work time will be allotted for the group activities and we'll make the workstation like at or slightly less than the cycle time. So if it is needed for 3 minutes, I'll make it some few seconds less than that. Okay. So it depends on whatever it is. How to combine the task into jobs workers means we'll take the help of the precedence diagram, then we'll make it to combine. Okay, in the job correct we'll be having the sequence of activities. But precedence diagram will help you to group the activities because we are going to work on work time with the group activities. Okay, so we'll group the activities. So procedure for line balancing is we discussed. We'll discuss the number of workstations we needed. That's what we are going to do now. Okay, so we'll give the blueprint. Then you group the individual tasks. You do the grouping with the help of the precedence diagram. and you go for how far it is efficiently working. Okay. So cycle time, we have defined the time interval between the completed products, leave the production line. So this is not normal. Okay, I'm not going line by line. Role of the manager, yes, I want to go for this one. Line balancing procedure. You might be expecting as a theory question. First step, the sequence of the job has to be done, which is the actual question first. Question கொடுத்திருப்பாங்கல்ல A, B, C, D. For example, you go for a question. When you find it on the page, very first question, see the practical problem. See, it's given in order. Task A, it has to be carried out. Then B, C. It is there a small hyphen, which means there's no preceding activity, which means A is the very first activity. And likewise, if you go for activity D, it's dash, which means A and D are the first two activities. Okay, if I go for B activity, A has to be done first. See, task that must be C. A has to be done first, then B has to be done. Okay. Then if you go for C activity, B முடிஞ்ச பிறகு C start பண்ணணும். So this is the order, which is the very first one, but is given in our question itself. Okay, so you need not worry about that. Then we'll go for drawing the precedence diagram. Okay, then we'll find the number of workstation required. To find the number of workstation required, we have to calculate the cycle time depending on number of units you're producing per day or per month or per year or whatever it is. Then you'll find the number of workstations needed. This is called as theoretical workstation. Theoretical means what? We take the help of the formula and calculate and we find the workstation. Workstation means two, three jobs might be done in one area. On the conveyor belt la move ஆகும்போது ஒரு 3 minutes நிக்குதுல்ல, that will be called as one workstation. See, one will be fitting the tire, one will be tight screwing the nuts, one will be fitting other things, one will be moving that helping or something like that. Okay. Then we'll round off to the next higher number. Then we'll assign the task. Then before assigning, we'll go for the activities, which means we'll go for some tiebreakers. Okay. We'll go for the activities. Then if you find any tiebreakers, see, I'm not going line by line because this is what we're going to do now. Okay. We'll go for the tiebreaker. There's a small correction needed. This is B and this is A. Because tiebreaker has to be done in order. Okay. So A and B மட்டும் கொஞ்சம் shuffle ஆயிருக்கு அது மட்டும் பார்த்துக்கோங்க. Then we'll continue the assignment. Then we'll assign the task. Then we'll evaluate the efficiency. If efficiency is unsatisfactory, then we have to go for rebalancing. So line balance ல வந்து efficiency இருக்கணுங்கிறதுக்காக தானே. If it's not efficient, we'll go for rebalancing. So these are the terms we'll be using now. So let me go for the calculations. When we talk about line balancing, this was once asked as a theory question. When we go for line balancing, we'll take the three important parameters. This may not be asked in the exam sometimes, but if you find that's a line balancing problem, we seriously request you to write it. And sometimes exam is asked for 6 marks question. In the exam, they ask only for the precedence diagram. If it is a 2 mark question, if it's a 4 mark question, stopping with the preceding diagram is fine. But 6 mark question, if on the line balancing is only precedence diagram drop on us or not, they request you to do this one. It's not a big calculation at all, it's an easy work. So to find the line efficiency, we'll find the sum of the task time. Task time, no, total time needed for doing the job. Okay. And actual number of workstations into workstation cycle time. You need not worry about this. Line efficiency is calculated in percentages. There will be a balance delay. Probably, if you go in calculating in percentage, I might be using only 80% effectively, which means the remaining 20% is the balance delay. Delay. Then we'll find the see our intention is to optimize, which means to reduce the idle time. So we take something called the smoothness index. Smoothness index is probably I don't know how far you have studied this year. This concept is so many times. Every time we use it. Every in the error வந்து கண்டுபிடிப்போம்னா summation, that is root of summation e square போடுவோம். E square is what's the idle error time idle time. So see this one. Summation root of summation idle time square. So maximum station time minus station time, the difference. If the smoothness index is 0 means what? It is perfectly balanced, which means what? No error. The smoothness index is 0 means it's not having any idle time, there is no error. Okay. So with the help of this, let me take over the problem. So let me go over the problem directly. Let's go for the question once. I want to go for the board work. This is the question given. This is the question given. Here the car has to be assembled on a conveyor belt. See the belt which is moving automatically. It's designed in such a way it's moving automatically is what it calls a conveyor belt. 500 cars are required per day. So how many units they have to produce? 500 units. Production time per day is 420 units. And the assembly steps and times for the wagon are given here. So what are the different? See, there we were saying that 92 stages are required to make that bus ready. Here, how many stages we have is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We totally require 11 stages or what you call as 11 steps to make this wagon ready. Okay. So how many units they are planning for in one day? That's the requirement is 500 units. Their production time is 420 units. Find the balance that minimizes the number of workstations subject to cycle time and precedence constraints. So looking out this table and looking out this word number of workstations and so on, you have to understand this is a line balancing problem or the word we use is line of balance. This will not be mentioned anywhere. You have to understand. Usually in the money workstation, etc., line balance down, the line balancing down. So what's my first stage? So I have to go for drawing the precedence diagram. Okay, so let me draw the precedence diagram. Precedence diagram is a normal networking diagram, which we do it in CPM and per record. So it's a normal networking diagram. To start with, you have to understand where is the starting point. Okay, see you find what is the table talks about, what is the job. Okay, the name of the job. Probably here to understand the better way, it's given A, B, C, D to be very easier. Probably if you go for the practical situation, we given us building, lading, screwing, the buttons, lines, and all. The task time needed is 45 seconds. See, it's given in seconds. Yeah, please you make a note of it. Here it is given in seconds, but whereas if you go for the production time, it's given in 420 minutes. So you have to make a go for conversion, minutes of seconds. And what is this task game? The description is given. Positioning, rear axle support, and hand fastening. Hand fastening. If you go for B, see, this is dash given, task that must proceed. This is the very first activity, very first job has to be performed. Then if you go for B, then A has to be finished. A என்ன பண்ணிருக்கீங்க? Hand fastening பண்ணிருக்கீங்க. Then it will go for the B job. What B will be done? What will be doing? Four screws to nuts. Screwing பண்றது. Nuts போடணும். Okay. Nut போட்டு fit பண்றது. Then after P, so usually I'll ask you to go this way. In the angle and the corner easier also. Don't go from left to right, go from right to left. It will be easier for you to understand the diagram. So after B, C has to be done, and there is a dash, which means D and A has to be performed simultaneously. So this is how it is done. So if I start, I place a start one, which means this is the starting point. So A will be started, along with that D will be started simultaneously. Is it okay? After A, what it is there? B. So after A, B job has to be started. Then after B, C has to be started. Okay, after B, C has to be started. Then if you go here, D is over. Then after D, E will be started. See, D அந்த part work பண்ணிட்டு இருக்கோம், E இந்த part work பண்ணிட்டு இருக்கோம். Then E is over. See, once C gets over, what are the jobs to be started? F and G. So F and G will be started simultaneously. Okay. Then after E gets over, see, two E's are here. After E gets over, H and I has to be started. So H and I. Is it okay? Then after, yeah, please make a note. F, G, H, and I. Everything has to get over. Then only I can start this job called J. Okay, so everything has to get over. So let me draw over here. Everything has to get over. Then only I can start with G. Is it okay? Then after J gets over, I can start K. Okay, Amma? So I can start with K. So this is my diagram, the series diagram. So from this you can understand, you can do some sort of grouping. Okay. A and D தனியா போகணும், but ரெண்டுமே simultaneously start பண்ண வேண்டிய situation இருக்கு. But ஒரே work station கொடுக்க முடியாது. நான் A ல இருந்து next B போகுது, D ல இருந்து E போகும். So some type of work station you have to define. So first step, precedence diagram step. Next we have to find the cycle time. Okay. So second step, I'll continue, I'll go in order. Second step is to find the cycle time. What is the production time? I'm not writing the formula. Please try to understand logically. What is the production time per day? 420 minutes. Okay. But it is given in seconds. All the task times are given in seconds. Can I get the total seconds? I think it's 195 seconds. Mhm. For one background to get ready, I need how much timing? 195 seconds. What is the production time per day? 420 minutes. But actually I have to do it in seconds. So into 60 divided by, this is for how many number of cars they are mentioning? For 500 units of car. So I have to make it for 1 unit. Okay, so what is the cycle time? 50.4 seconds. Okay, 50.4. Let us have it in terms of decimals. 50.4 seconds. So this is the cycle time. Now we have to find the number of workstations. ஒரு கார் மேனுஃபேக்சர் பண்ணதுக்கு 195 செகண்ட்ஸ் ஆகுதுன்னா the number of workstations needed. See, please highlight the number of workstations here we are calculating is a theoretical number, which means if we blindly follow the formula, we blindly do it and we apply it. But whereas when you go for applying all these jobs in the workstation, this may not be working. Okay. So number of workstation needed, how many total number of seconds to make one wagon is 195. Okay. Cycle time euro, that is முடிக்கிறதுக்கு 50.4. So how many workstations I might be needing? 3.87. Okay. 3.87. See, whether it's 3.87 or 3.37, when you go for rounding off, it's not mathematically rounding off, it's logically rounding off. We need minimum of 4 workstations. Am I right? 3 seconds மேல எடுக்குதுன்னா, that is 3 workstations மேல தேவைன்னா automatically எவ்வளவு வேணும் எனக்கு? I need 4 workstations. Okay. So I have to define workstation 1, workstation 2, 3 and 4. So I have to now check which job has to be in workstation 1. Okay. To check this, I need to take the help of this 50.4 seconds. What's the time needed for job 1? Let me put the details over here. 45 seconds. Let me write it over here. So this is 45 seconds. For B, it is 11. C, it is 9. D is 50. E, 15. F and G, 12, 12. H and I also 12. This is 8 and this is 9. Okay. So what is that? One workstation time. Number of workstation needed is how many? 4 workstations theoretically. So this is we have calculated in third step. What is the cycle time is? ஒரு workstation எவ்வளவு நிக்கும்? 50.4 seconds நிக்கும். So let me go for defining the workstation. If I name the workstation as 1, okay, please understand, if I define the workstation as 1, how long it will stand? 50.4 seconds. So which task has to, this is sequencing. Which task I have to carry? Task A. Okay. So task A is over. So what is the time needed here? 45. What's the idle time I have? Totally it is for 50.4 seconds. It is standing over there. So my idle time is 5.4. Okay. It's negative actually. 45 minus 5.4. 5.4 is negative. But actually 5.4 is the idle time I'm going to name it. So I need not have that minus sign or brackets. So this is the idle time. So this is the task. This is the task time. And this is the cycle time. Okay. And this is the idle time. Okay. Now I have to go for next activity. So as per the sequencing I'm going, when I talk about next activity, I'll go for workstation 2. We have to check whether we have to go for B or D. Okay. For this, we have this tiebreaker rule. So I have to go for tiebreaker rule before continuing for the second one. So what is this tiebreaker rule here is? There is 2 tiebreaker rule. First one A, second B. A is, first step is what you call as a primary rule. As per this primary rule, we check, for example, I'm checking with activity A. We'll check after activity A, how many are being followed here. See, for activity A, how many are followed after activity A? 1, 2, 3, 4, 5, 6. Okay. For activity B, how many are followed after activity B? 1, 2, 3, 4, 5. Okay. Activity D. See, for activity D also 1, 2, 3, 4, 5. See, now there is a tiebreaker. அப்போ எதுக்கு முதல்ல follow பண்ணோம்? See, first primary rule we apply to understand first workstation need to have which job. That's a primary rule. How we do the primary rule? We take one activity, we'll check how many stations are followed after the activity. So, நிறைய stations இருந்துச்சுன்னா அதை முதல்ல எடுத்துக்கணும். Okay. So for A, how many jobs are followed? 6 jobs are found, so that will be taken. So I have taken A. Next, I have to take B or D. I don't know. So we go for the second tiebreaker rule called as the secondary rule. Okay. When we go for secondary rule, for B, what's the time needed? 11 seconds. Okay. Let me write it here. 11. For D, what is the seconds needed? 50 seconds. Appo is lengthy? See, logic is this one. Whatever is lengthier, we'll do the job first. ஒரு டெய்லர் கிட்ட ட்ரெஸ் தரீங்க லென்த்தியான ஜாப் முதல்ல பண்ணுறது ஒரு டெக்னிக். So that technique is used only. Okay. See how we do for assignment problem, other things are not penalty method. We'll find the difference and we'll focus on the penalty. The same likewise here, the lengthiest one will be taken first. So D, how long it takes? 50 seconds. So D has to give it priority. So the next task will be assigned with respect to D. Okay. So A, B, D is over. Let me finish off the other rules also. Yes, can you help me out? So as per the second rule, which one has to be followed upon? D. So first A will be started, then D, then we'll go for B. So we are here. Next we'll go for C. Yes, tell me. For C, how many jobs are followed after C? 1, 2, 3, 4. Okay. For E, 1, 2, 3, 4. C, same way. Now I have to go for secondary rule for time breaking. So what's the secondary rule? For C, what's the time it takes? 9. The task time. For E, how long it takes? 15. So which one has to be done first? C has to, E has to, thank you first. E has to done first, then C. Okay. So next, let me go on with next set of values. So C and E is over. Next F. F, how many are carried out? Only 2. Okay. See, you cannot take G because F ko G ko sambandham illa. F க்கு J போகும். Likewise, G க்கு J போகும். So F க்கு 2, G க்கு 2. Okay. Then after H is also 2. Okay. And after I is also 2. Now still looks complicated, right? And moreover, if you go for F, G, H and I, it's all 12, 12, 12 and 12 seconds. Here no other go. You go ask for the question given. Question எப்படி கொடுத்திருக்கும் order? இதேதான order. Alphabetical order is given. See, F, G, H, I. I'm applying the primary rule. I'm applying the secondary rule. Even then, after applying the secondary rule, if the tie is still there, you break the tie up using the help of a question given. Okay. So in the question, it is following the alphabetical order. So simply or blindly we find the alphabetical order. F first, G next, H, I. Okay. Then we'll go for next set. So now we'll go for talking about J. After J, how many activity? 1. So no other go. There is no tiebreaker. Clearly you can fit with J. Is it okay? Clearly you can fit with J. And at last, it goes with respect to K, which is 0 activity, which means that's the ending activity. Okay. So automatically it goes for this K. Is it okay? When I started mentioning the station and when I started with this table, I started with A. Actually, you should not start with A. You have to check this rule and you have to start. இங்க வந்து நம்மளுக்கு கொஸ்டின் பார்க்கும்போது ஏ ஃபர்ஸ்ட்ங்கிறனால நான் ஸ்டார்ட் பண்ணல பிகாஸ் யூ ஹேவ் டு செக் த பிரைமரி ரூல் ஆஃப்டர் ஏ ஹவு மெனி ஆக்டிவிட்டிஸ் ஆர் ஹியர் 6 சி ஏ இஸ் த ஃபர்ஸ்ட் ஆக்டிவிட்டி ஆர் டி இஸ் ஆல்சோ ஃபர்ஸ்ட் ஆக்டிவிட்டி அங்க கொஸ்டின்ல ஏ கொடுத்தனால நான் ஸ்டார்ட் பண்ண முடியாது சி ஃபார் டி இஸ் ஒன்லி 5 for A it is 6 so which is having the lengthiest one A is having the lengthiest one that's why I have to start with D. Okay, so this is the primary rule. Then we'll go for secondary rule. Even though there is a type, it's not breaking out. Then we'll go for the question logic, like trial and error. Optimality sometimes may not be reached. So this is the order part. So let me now take it. So second activity, which is the second activity? D. What is the task time for D? 15 seconds, I think, right? So 50 seconds. 50, 50, right? Yeah, 50. What is the cycle time? The cycle time is common. Cycle time is 50.4 now. So what is the idle time? 0.4. Okay. Workstation 2 is over. Then go for workstation 3. A is over, D is over. So what is the next workstation I can have? Which job I can have? I can have B. Okay, I can have B. So what is the task time for B? It is 11 now. Okay. Probably till I get 50.4, I can use it. Okay, so probably after B, I have E. What's the task time for E? 15. After E, I have C. So what's the task time? So for C, it is 19, 9. Okay. So what's the cumulative value? 26. So I can still use D, F also. If I use F, it is 12. Can I get this value? This cumulative value? 47. So I think I have to stop over here. So cycle time is 50.4. So the ideal time is 3.4. Then I'll go for workstation number 4. See, theoretically we found only 4 workstations. But they are checking here, we can fit it in 4 workstations. If it's not possible, we have to borrow one. So after F it is G of I think it's 12 only. Then it is H, I, J. So for H was also 12, I remember. For I is also it's 12, I remember. It's 36. So I can add J also, I think. What is J? 8. So what is totally? 40, 36, 44. So 50.4. I cannot add K because K is carrying over 9 seconds. So if I add 9, it's going about 50.4. Another order of nonsense. We'll try to make it in decimal system. See, you say it's normal logical of rounding off in mathematics, but we'll not follow maths here. Okay, practically, the machine will stand only for 50.4 seconds in that workstation means which are 0.6 seconds that the machine ஓட முடியாது. Okay, இப்போ மகேந்திரா கார்ல பார்த்தோம்ல, when the unit stands here, there will be a platform, there will be a moving platform. That moving platform will automatically come closer to the machine. The work will be done, and the platform will be moved away from the machine. Then the unit will be moving. அப்போ நம்ம time cap பண்ணுவோம். Okay, so what's the ideal time here? 6.4. Okay, then at last, then I am in need of the workstation for K alone, and here it is 9. So what is my ideal time? 41.4. So I have a lot of idle time because of this 550. Probably if you want to avoid this now, ultimately have to focus on this fourth workstation. Fourth workstation வந்து கொஞ்சம் அதிகம் பண்ணா ஏதாவது எனக்கு பண்ண முடியுமா? Because already I have 6.4 seconds idle time. ஒரு remaining ஒரு 2.5 தானே 2.6 தானே ஏதாவது பண்ண முடியுமா செக் பண்ணலாம். This is all probably your job may be over. Okay. As I was discussing earlier, I once went for a program and I met Toyota's CEO. So he was saying this. அங்கங்க ஏதாவது மிச்சம் கொடுக்க முடியுமா? இங்க budgeting வேணாமா? Okay, so what we are finding here? We'll find line efficiency. Okay, balance delay. What's balance delay? 1 minus line efficiency and the smoothness index. SI. Let me go for the smoothness index. What is the smoothness index? Root of summation E square. The E is the idle time. So you have to sum up all the values. 5.4 square, okay, plus 0.4 square, plus 3 point, or you can have here itself E square. So 5.4 square was the value 29.16. Here it is 0.16. Here it is 11.56. Here it is 40.96. Here it is 1713.96. Add it together, getting 1795.80. Okay, so this is the value root of 1795.80, which is 42.38. 42% index, ideal index, which means your ultimate aim has to reduce this one. See, probably if we try to reduce, if I remove this workstation file, what would be the idle time? See, it's drastically reduced, right? Because of one workstation extra included, I am showing that my smoothness index is above 40%. Above 40% somewhat equal to 50% ideal Okay. Then we find this line efficiency. So what is the sum of the task time? Totally. Sorry. What is the sum of the task time? 195. Okay. 195. How many workstations I have? 5 workstations. And the workstation it stands for cycle time is 50.4. So what's the value? I'm getting this. It's actually calculated in percentages. 77% is effective. Okay. What's the balance delay? 100 minus 77, which is 23% delays and it's 4%. So that's some of the problem. Actually, it's a simple problem. We'll just go through. If any doubts, we'll discuss. Please join. So what we have done here is first we did the procedure. This is the order. Okay. First we have done the precedence diagram. Then we found the workstation cycle time, which means see this too is completely theoretical. When we talk about the third content, depending on the number of hours or seconds I need for manufacturing one unit is 195 seconds. Divided by 50.4 is how long it will stand in workstation. So how many workstations I need? Approximately 4 workstations. How do you find this 50.4? The complete production time per day, they are giving in the question. It's not I am taking it. They are giving in the question as 420 seconds, 420 minutes. But the task times are given in seconds. That's why we are converting into 60. And for this one day, they are manufacturing 500 units. See, my intention is to talk about one unit. They are talking about 500 units. So I divide by 500. So I talk about one unit. Okay. So how long it will stand there? 50.4 seconds. So that's why we call as a cycle time. So what is this 420? It's the production time per day. Okay, in minutes, then in converted to seconds. What is this 500 units means? Required output per day in units. Usually we take it in units. Okay. So when we talk about the theoretical minimum number of stations required, we say that NT. So usually we represent this as NT, number of stations required. Okay, NT. What is the task time for manufacturing one day on 195 seconds? So sum of the task time then divided by the cycle time which we calculated in the earliest. So second step, third step over. Then we go for assigning the rules. First is the primary rule which task has to prioritize depending on the largest number of following tasks. When I go for activity A, I have B, C, not B, C, B, E, F, yeah, B, C, D, F, J, K. So 1, 2, 3, 4, 5, 6. So I have to write it 6 over here. அதுக்கு பிறகு B பாத்தீங்கன்னா 5 இருக்கும், D பாத்தீங்கன்னா 5 இருக்கும். Then I have to go for the secondary breaker. So when you go for secondary breaker rule for B, how many seconds we needed is, I think it is for B it is 11 seconds. Yeah, 11 seconds, and for D it is 15. அப்போ ordering ல வந்து D will come. எப்பவுமே longest lengthiest will be first in the order for priority. Okay. So this is how we do it. Then we go for assigning the jobs in the workstation. Total number of cycle time is 50.4, which means that in that workstation we stand only for 50.4 seconds. So if I go for workstation number 1, as per the rule what we have done in the earlier step, my first step is to assign job number A in workstation 1. So assigning job A, the task time to complete given in the question is 45. So ultimately I can use only this 45 seconds because my total time is 50.4 cycle time. So there is an idle time of 5.4. Then this idle time square is to find the smoothness index. Then I'll go for second station. With the help of the tiebreaker, we have done the D first, then only B. So if I go for assigning D in the workstation, how long it is taking? 50 seconds. That one job itself is taking 50 seconds. So ultimately I have remaining 0.4 seconds. So I have to close with station D, station 2. Then I'll go for station 3. So when I go for station for C, it is 20. What's the value? For C, it is 9. For E, it is 15. So which has to come first? Lengthiest time has to come first. So E will come, then C will come. See, B has already there, then E, then C. Okay. So ultimately, if you add this, how much you getting? But 26, 34. Okay. 34 or 35? 34 or 35? 26 plus 9. 35 I'm getting. Okay. 35. But still I have till 50.4. So I'm trying to assign one more F. Sorry. If I check over here, F, G, H, I, all are carrying 12, 12, 12 and 12 equal number of task time. So I can assign in any way, but we go as per the question order. In a question sequencing பண்ணி So question order, so we go in this order itself. Which order? Question order. E, F, G, H, I. See, F is over, G, H, I, J. So if I take F over here, it's taking 12 extra. So it is totally 47. Ultimately, G, H, I, everything has to be taken to the fourth station. Okay. Then if I go for assigning these 3 jobs alone, only I'm using 36 seconds. Ultimately, I can add J, which is carrying only 8 seconds, which is now 44. I can use it. But whereas if I talk about the last job K, it is taking 9 seconds, but I don't have 9 seconds because my idle time left out is only 6.4. I cannot use the fourth station for job K. So ultimately, I had a new workstation. So theoretically, we need 4 workstations, but practically, it's not possible. So we are adding one more workstation. Job வந்து பிரிக்க முடியாதுல்ல. Screw போடும்போது பாதி screw நீ போடு பாதி screw நான் போட சொல்ல முடியாது. So that's about happening. So practically, we need 5 workstations. Okay. Then calculation of line efficiency. 195 is the total task time. So divided by number of workstations into workstation cycle time. So 77% is the line efficiency. Balance delay is 1 minus the. So this is the continuation of the earlier step. Usually we represent this in percentage, so 23%. And see, when we say 23%, it's actually talking about the imbalance or the idle time across the entire day. Then we go for the smoothness index, which is the root of sum of the error square. Error is the idle time in our case. So this is 42 point. If this is okay, can you just have a look on the second problem? Second problem, I'm not going to work lean operations. Seeing the word lean, they are not talking about making it lean. They are trying to make the waste zero waste. Okay, like no defective. So obviously, we learned this concept from Toyota. Okay, when we talk about reducing or minimization, is general concept. Everybody we talk. Okay, நீங்களும் time waste பண்ண கூடாதுன்னு நினைச்சீங்கன்னா ஆமா எல்லாரும் நினைக்கிறது தான். But Japanese concept is not that way. When they talk about reducing, they will not talk about reducing, they talk about zero, making it no. So in that way, we have this concept followed from Japanese Toyota that introduced the lean operations in the concept. So we have lean operation rooted from Toyota automobiles. When we say lean, what has to be lean? Which means we are talking about the waste. Waste in what way? Waste only not in terms of raw material. Waste in time has to be reduced. Which means what? If you are wasting your time means how you are wasting because you are making faulty product. So no faulty product, zero faulty product, which means what? No time is wasted. ஏன்னா நீங்க பக்காவா யூஸ் பண்ணிருக்கீங்க. Waste of investment in keeping high inventories. Yes, we have this EOK model. Also, when we talk about the EOK model, we have to spend for storage cost. Why we need to? Another next heading வந்து just in time. Just in time. See, 4.9 is lean operation. 4.10 is just in time invention. Okay. Then the waste of having idle workers. That's what we discuss in line balancing. Okay, so all these are included. So when we talk about waste, we are talking waste in 3 angles. Waste in time, waste in investment, waste in having idle workers. Okay. So what are the elements we have to consider? See, when we talk about this reducing the waste or making it zero, we cannot talk in one process or one case. Probably in the earlier example we were discussing with respect to line balancing, the fifth workstation, probably Toyota is trying to eliminate or reduce this one. They'll be eliminating this workstation K or K alone. So என்ன பண்ணா the earlier workstation ஓட include பண்ண முடியாது. So you had to completely check the supply chain. Supply chain is from the supplier of the raw material till it goes to the final customer. Not only that, you have to organize the workers in team. Okay. And the team should be conscious in what work they are doing. And they have to talk about perfect quality. And again, we have this Japanese concept saying that continuous quality improvement. Guys, on was saying continuous quality improvement. அதெல்லாமே உங்களோட தான். And how are you going to organize the operation product wise or cellular manufacturing using some functional or process layout? And how are you going to operate the facility in just-in-time inventory? JIT is just-in-time inventory. So this is actually a very topic, very small topic, and directly going for the very next heading, which is nothing but just-in-time inventory. When you say just-in-time inventory, they are giving a small introduction saying when we talk about the customer demand. See, what you talk about or what you say about customer demand is customer expect from the time on reach other than customer need. Okay, if I say that you order now, you wait for 3 months. Yes, I'm ready to wait, but will it be the same? My temptation might be reducing after the 3 months, right? The one happened with Tata now. Cost 1 lakh கொண்டு வர முடியும். It was around some 1.21 lakhs came for manufacturing data. 1.21 lakhs actually. அப்போ 0.21 lakhs is 20% இல்ல 20% hike ஆயிருக்கு cost விட சொன்ன cost விட first thing. And second one, they were not able to give the due date completed. Within the due date, they could not complete. So that was also one problem. So customer demand இருக்கும் போது the demand correctly utilize பண்ணணும். Okay. Talk about the demand has to correctly satisfied. We are talking about the external customers. But what about internally what is happening? So you have to talk about the external customers, and not only that, your internal job also how it's being done. Okay. So ultimately the goal is to provide the right quality level at the right place. So what is the objective? This is often repeated question. You produce only the products that customers want. Yes, நீங்க பாட்டுக்கு எதுக்கு தேவையில்லாம produce பண்ணிட்டு இருக்கீங்க? Not necessary. Customer products only as quickly as customers wants to use them. Yes, don't take a lot of time to give the commitment. Okay, make it faster. Make it with perfect quality, minimum possible lead times, with features that customer wants and no others. So அவங்களோட expectation close பண்றதுதான். No waste of labor, no waste of materials, no waste of equipment. Designate a purpose for every movement to leave zero idle inventory. This is what the word they expect. And produce with methods they reinforce the occupational development of this. So ultimately, overview of features or whatever this can be. Inventory has to be reduced at all stage of production, whether it's raw material or work in progress or finished goods. Reduce the inventory. Then improve the quality within the front and outside. You reduce the lead time. That is the time needed for setup and movements. Okay. Vendor control. See, we were talking about the die change. Because taking some 3 months for die change, I remember. Okay. Then vendor control and performance improvement is obviously that will be helping to improve our relationship, right? Buyer and supplier relationship, and how they move for multiple situation, supply situation. Then how we talk about buyers, it's all a simple strategy management. Porter's five forces model. The same thing we're discussing. Okay. Then continuous improvement is obviously we needed sometimes existing problems has to be corrected and we find new problems and new problems has to be corrected, then we find new problems. So it's like a continuous process, new never ending process. Total preventive maintenance has to be done and we have to do it if we get some gain, if we get some strategic gain. Else it's not going to make any positive efforts for us. Ultimately, நீங்க சொல்ல போனீங்கன்னா உங்களுக்கு ஏதாவது return பண்ணுவோம்ல. Why you are going to just spend and spend and spend? It's totally waste. So that's about this heading, which are actually a small heading. Can you just go through?